Okay, so this video is over 3.1, the properties of exponents. You've probably already learned some of these things, so it's going to be a review and then also combining a lot of things. So just a bunch of simplification. So let's just start off with multiplication of powers. When you are multiplying two expressions, like a to the m times a to the n, and a can be anything, and a lot of times we deal with x. So if I asked you, most people know what to do when I ask you to multiply x squared times x cubed. You know that that's 2x's times another 3x's, and if this means x squared and this means x cubed, then this means x to the fifth, which means we're adding the powers, 2 plus 3. Yeah? Sorry. So that means a to the m times a to the n is a to the n plus n. Okay? So when I multiply these expressions right here, negative 2x to the fourth times 5x to the sixth, they are in parentheses, but they're really, I mean, it might as well have just been written all beside each other because multiplication is commutative when you're multiplying things like this. In fact, you could, and what I meant by that was the order doesn't really matter. It's the same thing as saying negative 2 times 5 times x to the fourth times x to the sixth. Yeah? So I just think, okay, multiply the coefficients. Negative 2 times 5 is negative 10. And then you multiply the exponent, or the variables in x to the fourth times x to the sixth, and you just add the exponents. So that's x to the 10th. Okay? On this one, the next one, we are dividing. And so what I like to think of it is, if I asked you, so just as an example, if I asked you to divide 4 by 16, then that is the same thing as 1/4, and a lot of you know that because you're like, okay, I can divide everything by 4. So I divide by 4 here, I can divide by 4 there, and either way I get a simplified down to 1/4. Yeah? And if you had a 25 over 5, that would just be 5 because 25 divided by 5 is 5. Well, that's really 5 times 5 divided by 5, and you can just say that's the same thing as 5 times 5 divided by 5, which is 1. Either way, a 5 from the top and a 5 from the bottom simplify out, leaving you with just 5, right? And that's just 4 over 4 times 4. One of the 4's cancels out from top and bottom, and or simplifies out. 4 divided by 4 is 1, so you got 1/4. Okay? So if I have x to the fifth over x to the second, that's like saying I have 5 x's divided by 2 x's, and so 2 of those can simplify down to 1 from top and bottom, leaving me with just x to the third. So when you think about the operation, when we multiplied, we added the powers. Well, when we divide, we subtract the powers. So it's 5 minus 2, which is 3. So what if there's more x's in the denominator? So if it's, say it was x squared over x to the fifth. Well then, so 2 of those x's would cancel out from the top and the bottom, but that would leave me with 3 x's in the denominator, yeah? So it would be 1 over x cubed. That's still the same thing as x to the 2 minus 5, just like this is x to the 5 minus 2 is my answer. I think that's x cubed. They're getting kind of mixed up, but when you do this, you subtract the top power minus bottom power. 2 minus 5 is negative 3, though. And what we'll talk about, and what you've already learned before, is that if you have a negative power in the numerator, this is technically a fraction over 1, then it actually belongs in the denominator. Okay, and we can see that in 2 different ways. One, from subtracting, it equals negative 3, but if I just like look at what happens, 2 of the x's cancel out, leaving me with 3 in the bottom, then I'm just left with 1 over x cubed. Okay? So this is just a to the m minus n. Alright, when you subtract, or when you divide, you subtract. When you multiply, you add. Okay, so what I do is you can work this 2 different ways. So I'll write it down again. Okay, the first way would be to subtract and say 4, that's a 1, so a to the 1 minus 5, b to the 6 minus 1, and c to the 3 minus 3. Yeah? And so you subtract and you get 4a to the negative 4, b to the 5th, and c to the 0, and anything to the 0 power is 1, so that just goes away. And then you'd have to say, okay, well, a to the negative 4th, that actually means that that belongs, just kidding, in the denominator. Okay? The other way, which is the way I'm going to do it with you, is to just simplify. So instead of subtracting, go ahead and thinking it out. Okay, there's 1 up here and there's 5 down here. So if I cancel out 1 from each, then I'm left with 4 a's in the denominator. If I simplify out 1b with 1b up here, then I'm left with 5 in the numerator. And then 3 of these or 3 of those, they simplify each other out. So you're left with 4 b to the 5th over a to the 4th. And there you go. Okay, so it's just simplifying. Now, if you've got the power of a power, so if I ask you to find, we'll do something like that. If I ask you to find x to the 2 cubed, x squared cubed, that means x squared times itself x squared times itself 3 times, yeah? So that actually adds up to being 1, 2, 3, 4, 5, 6 x's, so it's just x to the 6. Or it's just these two numbers multiplied, 2 times 3. Okay. If it was x to the 3rd to the 4th, that would just mean x to the 12th, because that means there's 4 x cubes. Okay? So this is just a to the m times n. So I would just say, like, if you have 2 bases, when you're multiplying, then you add the powers. If you only have 1 base and you're raising to two different powers, then you multiply. Okay, so the other thing to know is that when you are raising 2 different things, which we've already talked about, but when you're raising 2 different things to a power, you actually can distribute the power. So if I asked you to raise 2x to the 3rd power, that means 2x times 2x times 2x, which might as well be 2 cubed times x cubed, which means when we're multiplying, we can distribute the power, which we've mentioned before. So that is going to be a 2 cubed and an x cubed, which is just 8x cubed. Okay, so 2 to the 3rd is 8. So when I do this, when I've got all of this, negative 2 times x to the 4th times y to the 3rd times z, all squared, that means you can work it one of 2 ways. You can write it out twice. So negative 2 x to the 4th y cubed z times negative 2 x to the 4th y cubed z, and then multiply them, and I'll do that in a second. Or you can distribute the power. Well, I'll go ahead and do it right now so you can see. Negative 2 times negative 2 is positive 4. X to the 4th times x to the 4th, you just add the powers because we're multiplying. X to the 4th times x to the 4th is x to the 8th. Y to the 3rd times y to the 3rd is just y to the 6th, so you add those together. And then z to the 1st times z to the 1st is z to the 2nd, so you add the powers together. Okay, so that would be that. In this case, I'm just going to go ahead and think of it as distributing. So I'm going to square negative 2. Negative 2 squared is a positive 4. I'm going to square x to the 4th, and I know that if I raise something with a power to another power, then I multiply the powers. So that's x to the 8th, so 4 times 2. That is just 3 times 2, and that is 1 times 2, which gives me z squared. And there you go. So sometimes, it will be feasible to do this expression, to multiply it out twice, to multiply it out with itself. But in general, some of the expressions are going to get kind of ugly, so you're going to want to understand this process where you just distribute the power. Okay. A 0 exponent, which again is something we've already talked about, it's already been mentioned, but I'm going to clarify just to make sure. Anything raised to the 0 power is 1. Okay? So when I see something like this, 6x to the 3rd to the 0 power, you can think of it as distributing and say 6 to the 0 and then x to the 3rd to the 0, which means 3 times 0, and it's just x to the 0. Or you can just say anything to the 0 power is 1. And so that would be my final answer for that one. Okay? Okay, one more thing. And I've already actually mentioned it on the notes in the notes already. But if you have a negative power, that just means that it belongs where it's not. And I can't just say in the denominator, because if you're in the numerator, that means you belong in the denominator. And if you're in the denominator with a negative power, that means you belong in the numerator. Okay? So, when we do this, you can do this a couple different ways. You can think of it as adding the powers. So, like, first off, we multiply 5 times negative 3, and that's negative 15. And then we say a to the third times a to the negative 4. And the rule for that is that if you're multiplying two expressions with the same base, you add the powers. So that's a to the 3 plus a negative 4, which is a to the negative 1. And then that tells me that the a belongs in the denominator. Just the a. I have a lot of people that will take the 15 with it. 15 doesn't have a negative power. It's only a that has a negative power, so be careful about that. And you can get this, or you can rewrite it. And as the expressions get larger, you might want to consider doing that. So I just think of it as, okay, I've got, well, I'll just go ahead and rewrite them individually. So I've got 5a cubed times a negative 3. That is a negative power, so it actually belongs down here. So remember, when we multiply fractions, we just multiply straight across. So I've got negative 15 over negative 15a cubed over a to the 4th, and then think about simplifying. So 3 of those simplify with 3 of those, leave me with 1 of those, so it's negative 15 over a to the 1st, or just a. The other option is, and the more we do these, the more steps we're going to be able to skip. You guys could just go ahead and say, okay, I know it's negative 15a cubed over a to the 4th. All of this is being multiplied, so it's all just basically one expression. 5 times negative 3, ooh, negative 15. And then a cubed stays on top, a to the 4th belongs on bottom, and then simplify. So negative 15 over a. Okay, so what we're going to do now is we're going to do some practice. So, if I'm asking you to do sorry, these Post-its just so you can focus. Okay, so this expression, I've got 3x squared y to the 3rd, all squared. So that means you can write it out twice and then multiply it that way, or you can just distribute the square. So that's going to be 3 squared, not 3 times 2, 3 squared, which is 9. And then you've got x squared squared, which is x to the multiply the powers, 2 times 2 is 4. And then you've got y cubed squared, which is y to the 6th. So don't forget, that's the same thing as saying 3 squared times x squared squared times y cubed squared. So 3 squared is 9, x squared squared is x to the 4th, and y cubed squared is y to the 6th, because that just means y cubed times y cubed. Okay. This one is kind of interesting. You can these problems, there's a lot of different ways to start approaching them, but hopefully we all get to the same result. I do want to talk about one thing though. If I multiply negative 1 times a negative 1, then that is positive 1. That's negative 1 squared, right? That's a positive 1. If I multiply negative 1 times negative 1 times negative 1, that's negative 1 cubed. That is a negative 1, because 2 of these multiply to give me a positive 1, and 1 times negative 1 is negative 1. And then if I have negative 1 to the 4th, then that is back to being a positive, because you've got a negative times a negative times a negative times a negative, and 2 negatives multiply to give me a positive 1, and then 2 more negatives multiply to give a positive 1, you multiply those and you get a positive, okay? So the goal is to understand that anytime you raise a negative number to an even power, it becomes a positive, but if you raise a negative number to an odd power, it stays negative, okay? So I'm going to think about this in a couple different ways. So first, this is negative 3 to the negative 3rd power, which literally just means 1 over negative 3 to the 3rd power. So I have a negative power, and then I just move it to the denominator. It's still a negative 3, but now it's just raised to the 3rd power. So that is negative 3 cubed, and 3 cubed is 27, so negative 3 cubed is negative 27. Okay? When you multiply, when you raise this, so I worked it out with the number because you need to think about that a little bit differently. These are a little bit easier though. I have x to the negative fourth to the negative third, and remember when we do that we just multiply the power, so negative 4 times negative 3 is a positive 12, so that's just a positive 12 in the numerator because it's got a positive power. Whereas this one right here, if I multiply this, then I get, well, let me go ahead and write this. So that's x to the 12. And then when I multiply this, I get y to the negative 9th, which just means it belongs in the, it's a positive 9. Once you move it, it has a positive power. So this is the expression when I distribute the power of negative 3, so negative 3 to the negative third power. That's x to the positive 12 because you multiply, and that is y to the negative 9th. Anything with a negative power, though, needs to move. So that stays, these two go. Okay? So negative 3 cubed is negative 27, so I just put that in the denominator. Y to the negative 9th just means y to the 9th in the denominator. The only thing that I would expect you to do, and I hope you know this already, is to move the negative either in the front or to the numerator, okay? Because I would not want the negative in the denominator. And you're done. Okay, so let's get a little bit more interesting with it. This is 2x to the third, y to the negative third, all to the negative second, times negative 1, x to the negative 7th, y to the negative 6 to the second. Okay, so when I'm doing this, the first thing I'm going to do is distribute my power. So this is 2 to the negative second. And what I'm going to do is I'm going to draw a fraction bar, and I'm just going to start placing things where they go. So 2 to the negative second is just 2 to the second in the denominator, okay? This is technically like all over 1, so we're dealing with a fraction. Everything right now is in the numerator, so if it has a negative power, it's going to go to the denominator, okay? So 2 to the negative 2 is just 2 squared in the denominator, which is 4. Okay, so that belongs in the denominator. X to the, when you raise x to the third to the negative second, that means you multiply the powers. It's x to the negative 6, so that belongs in the denominator. Y to the negative third to the negative second is just y to the 6th, and that belongs in the numerator. It's negative 2 times negative 3. And now we start multiplying this. And remember, this is all multiplication, so it might as well all be just in the same big thing. So I got negative 1 squared, so times negative 1 squared. Negative 1 squared is a positive 1, so you don't have to write it down, but I'm going to go ahead and write 1. I didn't need that dot. I don't know why I did it, but maybe because it was weird just hanging out 1. But. Okay, next I need x to the negative 7th to the second. That means x to the negative 14th, or x to the 14th in the denominator. And then we have y to the negative 6th to the second, which is just y to the negative 12th, which means that also belongs in the denominator. Okay? So at this point right now, I'm ready to simplify and find my final answer. What I notice is that in my numerator, I only have y to the 6th times 1, but it's just y to the 6th, divided by y to the 12th, which tells me that I can simplify out 6 from the top and 6 from the bottom. So 6 of these cancel out with 6 of those, leave me with 6 of them left. So I know my final answer is going to have y to the 6th in the denominator. Okay. I also notice that I've got two different x terms in the denominator, and when I multiply two x's, then I add their powers. So 6 plus 14 is 20, so that just becomes x to the 20th, and then that 4 is just kind of in the denominator, so it just hangs out right there. And that is my answer. Okay. Now we do this one. Okay, so it's already in a fraction force, but I'm going to, and you could do the whole like subtracting the powers 4 minus a negative 2, negative 2 minus a negative 5, negative 1 minus 2, and then moving from there. But I find it's easier to just do this. I'm going to write things where they belong. The 12 belongs on the top, doesn't have a negative power. X to the 4 stays. Y to the negative second, that has a negative power, so it goes. Okay? Z to the negative 1 has a negative power, it goes to the denominator. Z to the first. And then I just keep with the same fraction, just now do it with the other parts. Negative 3 doesn't have a negative power, so that stays, so we're times negative 3. X to the negative second has a negative power in the denominator, so that means it comes to the numerator. Y to the negative fifth has a negative power in the denominator, so it belongs in the numerator. And z squared has a positive power, so it stays. And then it's just a matter of simplifying. So I'm going to go with coefficients first. I've got a 12 and a negative 3. 12 divided by negative 3 is negative 4. So I know the numerator has a negative 4. Or the negative could be out front. I have two different x terms. They're both in the numerator, so I'm just going to add the powers. So that is x to the 6th, 4 plus 2. I have a y in the denominator and a y in the numerator. Sorry, I just said that backwards. I have a y in the numerator and a y in the denominator. So what I'm going to do is I'm going to simplify out 2 of those. With 2 of those, leave me with 3 in the numerator. And then the z's are both in the denominator. Z to the first and z to the second, so we just add the powers, z cubed, and there's my final answer. Okay? If you had worked it with just the properties of exponents the way that we talked about it first, 12 divided by negative 3 is negative 4. This will be x to the, when you divide, you subtract the powers, 4 minus a negative 2, y to the negative 2 minus a negative 5, and z to the negative 1 minus 2. And so that becomes negative 4x to the 6th, y to the, that's negative 2 plus 3, that's 3, and then that is z to the negative 3, and then I would just have to recognize that that means the z moves to the denominator, and there you go. So it's whatever you like, whatever you prefer. Okay? Let's do this one. So pause it if you need to so you can write the problem down, but then I'm just going to start working it. Okay? You could go ahead and combine. If you want to, you could go ahead and start simplifying. You could do all sorts of things. I'm going to write this down again because I'm going to approach it a couple different ways. So the first thing you could do, well, the interesting thing about these types of problems is that there's no particular like first step. It's just whatever you see, whatever you want to do. You could multiply the numerators and multiply the denominators and then simplify from there. You could move this down here. It's kind of whatever you want to do. So I'm just going to go ahead and I'm going to rewrite it. So I'm going to say 16. So the numerator, 16. I like to put the coefficients first. I'm going to put 16. I've got x squared. I've got y in the numerator. The only other thing in the numerator is x to the third, which I think belongs in the denominator. So I'm going to put it down here, x to the third. So that is going down here. The 4 and the 32 I could multiply, but I'm going to leave them out. And I'll show you why in a second. 4 times 32, and then x to the fourth, and then y to the fifth. And then simplify from there. So you could just go ahead and say these two combine to x to the 7th, and then start simplifying. So you've got 16x squared y divided by 4 times 32 x to the 7th y to the 5th. And then 16 divided by 4 is 4, and 4 goes into 32 8 times. And so that's a little bit easy way to do it. Another way would be 16 divided by 32 is 1/2. 16 goes into 32 2 times, and 2 times 4 is 8. Either way, you'll get there. 2 of those cancel out with 2 of those, leave me with 5, and 1 of those cancel out with 1 of those, leave me with 4. So everything simplifies in the numerator, leave me with 1. I've got an 8, x to the 5th, and y to the 4th. My instinct is to go ahead and just start like simplifying from the very get-go. So I probably would move this down there, I probably would just say x to the third. Just kind of mark it out. And then I would just start canceling out. 2 of those cancel out with 2 of those, leave me with 2. One of the y's, one of these y's cancels out with one of those y's, leave me with 4. 16 and 32 simplified into 1/2. And then I've got x squared and x cubed, so that's x to the 5th. So again, 4 times 2, which is 8. And then x to the 5th, because you simplify x squared and x cubed, add them up, add the powers, and then y to the 4th. Sorry. So it's kind of however you see it. But as long as you don't get the properties wrong, it doesn't matter the order that you work or how you work it. Okay? Okay. I'm just going to draw a fraction, and I'm going to start placing things where they need to go. So this 1 stays in the numerator, whatever. A squared, I'm going to put in the denominator. B cubed, that's b to the negative 3 in the denominator, which means to me it needs to move to the numerator. And then I'm going to distribute this power. So a to the 2nd to the negative 1st power, that means, remember, we multiply those. So that would be 2 times negative 1, which is negative 2. Technically, this is all over 1, so it's in the numerator right now, which means that belongs in the denominator with that one. And then b to the negative 3rd to the negative 1st is just b to the 3rd, because you multiply the powers. Negative 3 times negative 1 is 3, so that's b cubed. And then when you're multiplying, you just add the powers. So b to the 6th over a to the 4th. And that would be my final answer. On this one, I'm going to distribute the powers, and, well, yeah, I'm going to go ahead and distribute the power. So first I'm going to draw a fraction bar, and then I'm just going to start placing, it doesn't need to be that big, but whatever. And then I start placing things where they go after I distribute the power. Now, we are raising this to the negative 2nd. Yeah, I'm going to do this a couple different ways. So this one, when you multiply x to the 2nd times y to the 3rd all to the 2nd, you do distribute. It's the same thing if you divide. If I have x squared over y cubed squared, I can still distribute the power to the top and the bottom. Okay? So as long as it's not addition or subtraction, that's when you can't distribute the power. So that becomes j to the positive 2, because it's negative 1 times negative 2. So that will now stay in the numerator. K to the 4 to the negative 2, so that means multiply k to the negative 8th, which means it just k to the 8th in the denominator. M to the negative 6 to the negative 2nd is just m to the 12th, which is a positive, so it stays in the numerator. And then we just go for the denominator. Negative 2 times negative 4 is positive 8. It's a positive power in the denominator, so it stays in the denominator. Negative 2 and negative 5, that is positive 10, so it stays in the denominator. And negative 2 times negative 2, m to the negative 2nd to the negative 2nd is m to the 4th. It's a positive power, so it stays in the denominator. And then we just simplify. J's, there's 2 here and there's 8 there, so that leaves me with 6 in the denominator. I just wrote an 8. Okay, so there's 6 of those left in the denominator. The k's, let's see, there are 8 in the denominator and 10 in the denominator, so that combines to 18 in the denominator. We'll just add the powers. And the m's, there are 4 of them in the denominator and 12 in the numerator, leave me with 8 when I simplify out 4 from each. So that's m to the 8th. And there we go. So I like to distribute the power. You could have simplified in the interior first and just said j to the 1st belongs in the denominator, k to the fourth stays, m to the negative 6 belongs in the denominator, j to the negative fourth needs to go up to the numerator, k to the negative fifth is in the denominator with a negative power, so it belongs in the numerator, and m to the negative second needs to go to the numerator as m squared. And then simplified, k to the ninth, j to the third, and m to the fourth, and then raise it to the negative 2. So even here you've got options. You could distribute a negative 2, so that's k to the negative 18, which means it belongs in the denominator. That is j to the negative 6, which means it also belongs in the denominator. And this is m to the negative 8th in the denominator, which means it belongs in the numerator. Or, I don't know if you know this, but if you have a negative power, if I were to raise an expression all to the negative 1, it just puts it in the denominator, like we said. So this just becomes, you can come in. So this just becomes k to, it's okay, just wait a second. So you could just flip it and say k to the ninth, j to the third, and m to the fourth, all squared. So if you have a negative power, you can just flip the fraction, and then you distribute your power. So m to the 8th, k to the 18th, and j to the 6th. Okay? I actually have, yeah, that's okay. I have a couple of examples, but I'm going to post those because I don't have enough time to put them in the video anyway. I'll work them out and post them on iLearn, and then we'll just work on the assignment tomorrow. Okay, so make sure you take these notes down.